I'm going to continue our section 7.1 discussion, but today we're going to get a little more AP style question. And here we're going to take a region, we're going to be able to find the area of it, but we're going to find the equation of a line that's going to divide this region in half. So what does that mean? Well, let's look at example number 1. Here we're going to give a function, a couple functions, f of x equals x squared plus 2. So if I graph that, x squared plus 2, we come up 2 on the y-axis. It's going to be parabolic. G of x equals 0. Well, here's our 0, just the x-axis. The x values are going to be 1, so we'll draw in 1 there, and 4. And it tells us that it wants to find some value a, such that the equation x equals a divides the region into 2 equal parts. Well, x equals is going to be a vertical line. So I want to draw in a vertical line through here somewhere so that these two regions are going to be equal to each other. Well, how do I do that? Well, the first thing I can do is find the area of this region altogether. So I can find the integration from 1 to 4 of x squared plus 2 minus 0 dx. Again, that 0, a placeholder, not required, not necessary, but useful, especially as we get into later on questions. So I can go ahead and integrate this. I get x to the third over 3 plus 2x from 1 to 4. Plugging in my 4, we have 64 thirds plus 8 minus, plugging in our 1, we have 1/3 plus 2. So my area is going to be what? 63 thirds here plus 6. 63 thirds is 21 plus 6, or 27. So I know my area overall is 27. Well, if I want these to be equal parts, I know that I need half of an area here and half an area here. I'll have a 27, gives me 27 halves, or I can go 13.5. And I want that to equal the integration. Well, I can go from 1 to a, or I can go a to 4. Doesn't matter. I normally like to use the smaller numbers, so we'll go from 1 to a of f of x, which is x squared plus 2, minus our 0 dx. So now I know that 13.5 is going to equal our x to the third over 3 plus 2x from 1 to a. 13.5 or 13.5 equals a to the third over 3 plus 2a minus, plugging in our 1, we get 1/3 plus 2. I can go ahead now and solve this equation. I have a cubic function. It's going to be kind of on a cumbersome side, so it looks to me like I'm going to have to find the zeros of this function. So 0 is going to equal a to the third plus 2a. Here I have negative 1/3 minus our 2, or negative 2 1/3. And I'm going to bring in my 13.5. So if I take my negative 1/3 and I subtract the 2 and I subtract 13.5, I'm going to get my negative 15.833 blah 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 blah. I could change it to a fraction, math fraction, and end up with negative 95 over 6. This is going to be a calculator question, so we can use either one. We could store that, be able to go up and find that value. Essentially, we're going to come over here to our y equals, and we're going to go ahead and find that value. So again, we can use our, instead of a, we can use x. So we have x to the third divided by 3 plus 2x minus, I'm going to go ahead and use the fractional value there since I have it, 95/6. And what am I looking for? Again, we're looking for the zeros of this function. And I know that I have to be between the values of 1, and 4. So if I look, I'm looking at that point there. I can go and calculate, or second trace, my 0 this time, which is 2. My left bound, I know I've got 2 there. It looks like just over 3. So I'm going to go my left bound of 2. My right bound, I can go to 4. If you want to be pretty precise or not precise at all, you can go from 1 to 4 because you know that value has to be between those two values. We hit enter and we end up with an A value equal to 3.074, accurate to 3 decimal places. So that's going to be the equation that's going to allow us to separate this area or this region into 2 equal regions. Now if we do this with the x-axis, we can also certainly do it with the y-axis, which becomes a little more fun. Of course it becomes fun. We enjoy fun problems, don't we? So let's go ahead and look to see what we have. We have given y equals 0. We have y equals 4 minus x squared. And we want to find a value b such that y equals b divides the region into 2 equal parts. So again, 4 minus x squared. Well, we should know that that is going to look parabolic. We're going to go through negative 2 and 2. Y equals 0 is the x-axis. We know we go through the value here, 4. But what makes this problem more complicated and interesting is that now we want a y equals b line. So y equals b is going to be a horizontal line. So now, if I integrate, I'm going to go from 0 to b, and b to 4 to be the same. And I'm integrating with the variable of y instead of the variable of x. Well, there's a few things that we should hopefully notice about this function. One, this function is an even function. If this function is even, we know that the left side of the x-axis or the y-axis is going to be the same as the right side of the y-axis. If that's the same, and I want these two regions to be the same, I know that this line is going to cut this area in half as well. So that all becomes important because I'm integrating in the variable of y's. I'm going to have to get this equation in x equals form. So I'm going to be looking at y equals 4 minus x squared. Solving for x, I can subtract my 4. Divide by my negative, I get negative y plus 4 equals x squared. And I'm going to take the square root. Remember, when I take the square root, I get a plus or a minus. So I get negative y plus 4 equals x. So now what are we looking at? Well, we can find the area of this region altogether to start. So I can integrate 0 to 2's of my function. My top curve is 4 minus x squared dx. I'm going to be lazy today. I'm going to go ahead and put that into my calculator. So math 9. I'm going from 0 to 2 of 4 minus x squared dx. Don't forget to multiply that by 2. So that gives me an area of 10 2/3. But I know that each of these is equal to itself. So I'm really only interested in 1/4 of it. So I'm going to divide that by 4. So I know each of these regions is going to be 2 2/3. And it's kind of hard to see that, but each one is equal to 2 2/3. How does that help me? Well, now, if I integrate from 0 to b of my top curve, well, my top curve in this case is the positive radical part of this. So the square root of negative y plus 4 dy. And I want that to equal 2 2/3. So knowing that it was an even function allows us to remove this part here, because we know that these two parts are going to be equal, and then these two parts are going to be equal as well, because we're cutting it with that y equals b line. So I've made my problem a little easier. I'm only now going from 0 to b of the square root of negative y plus 4 dy. Well, can we integrate this? Not quite. Because remember, we have to make this into a fractional exponent. So we have negative y plus 4 to the 1/2 dy. I can't integrate a quantity to an exponent, but I can come off to the side and let u equal negative y plus 4. du equals a negative dy. Can't use the negative, so I have a negative du equals dy. So now I'm integrating, instead of from 0 to b, if I plug in my 0, I'm plugging in 4, to the negative b plus 4 of the negative u to the 1/2 du. And we want that to equal 2 2/3. Well, going ahead and integrating now, I can integrate u to the 1/2. That gives us negative u to the 3/2. I'm going to divide by 3/2, or multiply by 2/3. I'm going from 4 to negative b over 4. I'm going to plug in my negative b over plus 4. I'm going to plug in my 4. So I get this equal to negative 2/3 of, since that's a constant, I can do my negative b plus 4 to the 3/2 minus plug in my 4 to the 3/2. And that's going to all equal 2/3. It looks kind of cumbersome, but we can actually clean this up quite a bit. 2 2/3 is 8/3. So that equals a negative 2/3 times our quantity of negative b plus 4 to the 3/2 minus 4 to the 3/2. Remember, 4 to the 3/2 we could write as 4 to the 1/2 to the 3rd. 4 to the 1/2 we know is 2 to the 3rd, so that gives us 8. Now I can go and fix this 8/3. Coming up to the top here, we can multiply both sides by negative 2 or negative 3/2. So negative 3/2 times 8 gives us a simple negative 4 equals negative b plus 4 to the 3/2 minus 8. Adding 8 over, we have 4 equals the quantity of negative b plus 4 to the 3/2. I can undo the 3/2 power by taking it to the 2/3. So I have 4 to the 2/3 equals negative b plus 4. I pull out my calculator at this point in time. 4 to the 2 divided by 3 is going to give us 2 and almost a half. We're going to subtract 4 from that, and we're going to take the negative of that, and we're going to end up with an answer of b equal to 1.480 to 3 decimal places. And that's a little more cumbersome of a problem. However, it's something that we can do. And that is being able to divide a region into 2 parts.